Well, in the mid-1990s, uh, the International Space Station program was created out of a previous effort to create a permanent space station, which NASA, of course, was um, very hopeful and uh, really committed to doing. That was their other big goal besides the permanent shuttle. And they got approval for that station in 1984 from President Reagan, but the whole program, the station program, was just completely mired in bureaucracy and was being redesigned again and again. And people in Congress were getting into it and making NASA redesign the station. Well, finally, after it barely escaped being canceled, the station was transformed into an international program by President Clinton, who invited the Russians to take part. And with that in mind, even though the station wouldn't be ready for many years, NASA had the idea that we needed to get some experience working with the Russians and experience also in sending astronauts up to live on a space station. Well, the Russians had a space station called Mir that they had launched in 1986, and it was composed of several different modules, and then every once in a while they'd launch a new module and add it on, and it was getting to be quite elaborate and roomy. And so we started a program of joint missions where we would send astronauts up to the Mir space station. And one of them was Shannon Lucid, who had flown on the shuttle and who in 1994 spent 6 months on Mir, which gave her the endurance record for American astronauts at that time. And you see her there on the treadmill in Mir, exercising just to maintain her cardiovascular health and prevent other kinds of ill effects from long-term exposure to weightlessness. Now, it was a very fruitful program, but it was also a very stressful program. It was not easy to work in such different cultures. NASA often clashed, people from NASA often clashed with people in the Russian space program. Sometimes the training was not adequate. There was a lot of frustration, but they got through it, and the Shuttle Mir program ended up being a tremendously groundbreaking phase for NASA. In 1998, John Glenn, the hero of the early Mercury program, got a chance to fly in space again at age 77. And he went up on the Shuttle Discovery as a member of a 7-person crew. And you see him here. Looks like he's having the time of his life, revisiting Earth orbit and having a chance now to float around, of course, and something that he never could have done on Mercury. And it was really a mission that, they said it was going to give new information about the aging process. Since Glenn was the oldest person ever to go into space, by looking at the effects of weightlessness on him, they'd have data points that would relate to aging on Earth. And that certainly may be, but I think the real impact of the flight was just at a time when there was very little glory left in the space program. This was a taste of the old glory, and a really welcome, nostalgic episode that kind of fulfilled people's desire to have heroes again. And it's not that the astronauts who flew on those shuttle missions weren't heroes, but the level of attention was nothing like it was in the old days. So Glenn was kind of a link with that early era of space exploration when everything was exciting because everything was happening for the first time. Well, in the end of the 90s and the beginning of the 21st century, the International space station era began. The first modules for the station went up around the turn of the century, and the first team of astronauts and cosmonauts to live there, they arrived at the station at the end of October of 2000, and they spent about 5 months there. And here you see a Russian cosmonaut named Yuri Gidzenko inside a kind of a storage module. It's called the Multipurpose Logistics Module, and it's made by Italy, and this one is called Leonardo. Look how big it is. Look how roomy it is. And this isn't even one of the main modules on the station, but this just kind of gives you an idea of a whole new ball game. And of course, as time went on, the station was added to. Unfortunately, there was another tragedy waiting for us, not on a station mission, but a shuttle mission that was devoted to science, one of the few shuttle missions now that was not related to the station. This was just about scientific experiments, and this time the tragedy occurred during re-entry. There had been a piece of debris during launch from the external tank of the shuttle that had ripped off the tank and struck the leading edge of one of the shuttle's wings and made a gash, a hole in the shuttle's insulation. This was not discovered by anybody on the ground or in space. And so on February 1st, 2003, when this crew re-entered the atmosphere, the extremely hot gases of re-entry got into the shuttle structure through that hole in the insulation, and the shuttle was broken up and burned up in the atmosphere. And it was a terrible day and another moment of reckoning for NASA and the space program. Yet another accident and investigation, and once again, they were able to determine the causes and find solutions. And through that determination that is so characteristic of NASA and the space program, they were able to keep going. Now, it did mean when the shuttle started flying again in the summer of 2005, it did mean that we really had to have a new degree of watchfulness and vigilance. And so there was extensive photographic coverage of the shuttle when it lifted off, and that film was analyzed as soon as it got into space. There were people on the ground looking at it to see if any debris had come off the tank that could have hit the shuttle. And when the shuttle got up to the space station, the commander, in this case Eileen Collins, who was the first woman to command a shuttle, this was her second time as a commander, she put the shuttle through a kind of a backflip, and the astronauts on the space station took telephoto lenses and cameras and photographed the shuttle, and then those pictures could be sent down to Mission Control to be analyzed for any problems with the tiles. Now, there was one minor problem with a tile that needed to be dealt with, and that was that there was a little kind of a card called a gap filler, and it was sticking out. It wasn't supposed to be sticking out, but it was. It was sticking out by a small amount between two tiles. And the fear was that this gap filler sticking out like that into the airflow of reentry might cause excessive heating at that spot. And they didn't want to take that risk, so Steve Robinson, one of the astronauts on the flight, went outside and was able to pull the gap filler out and solve the problem, because it was not actually needed to maintain the safety of reentry, but if it had been sticking out like that, it would have been a potential problem. And on the right you see Steve inspecting the underside of the shuttle before he does that repair.